out here, nothing ever truly disappears. Light travels for billions of years, carrying information from stars that no longer exist. Some of that light is reaching you right now, which means the past is still arriving. We like to imagine time as something that flows away from us, moments falling backward into nothing. But the universe doesn't seem to work that way. Physics has a no delete button. So if nothing is erased, why does it feel like the past is gone? Richard Feynman believed that understanding begins with honest questions. So, here's one to sit with. Do you believe the past truly disappears, or do you think the universe keeps a record in ways we don't notice? If you have a thought, you're welcome to share it below. Chapter 1. The strange feeling that time is slipping away. There's a moment that happens to all of us. You're sitting quietly in the evening. Maybe there's a lamp glowing softly in the corner. The room is still, and somewhere in the background you hear it, the faint ticking of a clock. Each tick marks a second. Each second gone. And suddenly, without warning, you feel it. That quiet, uncomfortable awareness that time is moving. Not just moving, slipping. Like sand falling through your fingers no matter how tightly you hold on. You think back to this morning. What did you do? What did you say? It feels so recent, and yet it's already gone. You can remember it, yes, but you can't touch it. You can't return to it. It exists now only as a kind of echo inside your mind. And the further back you go, last week, last year, childhood, the more it feels like those moments have vanished completely. As if they were never real at all. As if they were just dreams that dissolved the moment you woke up. We carry this feeling with us constantly. This sense that the past is lost, that every moment we live is immediately swept away into some vast, unreachable void. We take photos to hold on. We write in journals. We tell stories. Anything to prove that those moments were real, that they mattered, that they still exist somehow. But deep down, we suspect the truth. They're gone. The past is gone. And no matter how hard we try, we can't bring it back. This feeling, this quiet grief over time's passing, is so familiar that we rarely question it. It seems obvious, self-evident. Of course the past is gone. That's what past means, doesn't it? The part of time that no longer exists. But what if that's not quite right? What if the past hasn't disappeared at all, and we've just been looking at it the wrong way? Richard Feynman, one of the greatest physicists of the 20th century, had a peculiar habit. He liked to start with the most obvious, universally accepted ideas and quietly take them apart, not to be difficult, not to show off, but because he believed that the only way to truly understand something was to question it from the ground up. And when it came to time, to this ancient human feeling that the past slips away, Feynman had something deeply surprising to say. So before we move forward, let's sit with this feeling just a little longer. Let's notice how real it is, how instinctive, how much of our lives are shaped by the belief that once a moment passes, it's gone forever. Because once we've felt that fully, once we've acknowledged how deeply we believe it, we can begin to ask a question that changes everything. Is the past really lost? Or is it still here, just quieter than we thought? Chapter 2. What do we actually mean by the past, now that we've felt how fleeting time seems? Let's slow down and ask a deeper question. What do we actually mean when we say, the past? It sounds like a simple question. Almost too simple. But Feynman would tell you that the simplest questions are often the most important ones, because if you don't know what you're talking about, if you haven't clearly defined the thing you're trying to understand, then you're just shuffling words around. You're not really thinking. So let's think. When you say the past, what are you referring to? Is it a place, a thing, a substance? Most of us, if we're honest, don't really know. We use the word constantly, but we've never stopped to pin it down. We treat the past as if it's a location, somewhere back there, behind us, like a room we've walked out of. Once we leave, the door closes. And what's inside that room? Gone. Inaccessible. Lost. But here's the problem. The past isn't a place. It's not a physical location you can point to. You can't travel backward down a hallway and find yesterday waiting for you in a corner. So if it's not a place, what is it? One way to think about it is this. The past is just a label we give to certain arrangements of matter and energy. It's a way of talking about the universe as it was, compared to how it is now. Right now, you're sitting somewhere. Your body is in a specific position. The air molecules around you are moving in a particular way. Light is bouncing off surfaces. Your neurons are firing in certain patterns. All of this exact configuration of everything, is what we call the present. But notice what we're really saying. The past is just a previous configuration of the same universe. It's not that the universe was replaced by a new one. It's not that the old version was erased and a fresh one was written over it. It's the same universe. The same universe. The same matter. The same energy, just rearranged. Think of it like a deck of cards. You shuffle the deck, the order changes. The previous order, the past order, is gone in the sense that the cards are no longer arranged that way. But the cards themselves, they're still right there in your hands. Nothing disappeared. The deck didn't get smaller. It just changed. And yet when we talk about time, we don't think this way. We think the past vanished. We think it was erased. But really, all that happened was things moved. Energy flowed. Particles shifted. The universe continued. Feynman loved this kind of reframing. He had a way of taking an idea that seemed mysterious and poetic, like the past is lost, and translating it into something physical and concrete, not to make it boring, but to make it real, to show you that the universe doesn't deal in metaphors. It deals in atoms and forces and motion, and when you look at it that way, the past starts to seem less like a ghost, and more like a trail. So maybe the question isn't where did the past go? Maybe the question is, what happened to the configuration we used to call the past? Did it disappear, or did it just transform into something else? And if it transformed, if the information about what happened is still embedded in the universe, just in a different form, then maybe the past hasn't vanished at all. Maybe it's just hiding in plain sight. If the past is not a place, then perhaps it hasn't gone anywhere at all. Chapter 3. The universe never forgets. It only transforms. Here's something Richard Feynman understood better than most. Nature doesn't throw things away. It doesn't erase. It doesn't delete. It doesn't make things disappear into nothingness. It transforms. It rearranges. It scatters. But it never ever simply removes something from existence. This is one of the most fundamental principles in physics, and it shows up everywhere. Energy can't be created or destroyed, only converted from one form to another. Momentum is conserved. Information, in a deep and technical sense, is preserved. The universe is a closed system. Nothing leaks out. Nothing gets lost. And if that's true, if the universe really doesn't forget, then every event that has ever happened is still here. Not in the way we remember it. Not in a form we can easily recognize, but somewhere, woven into the fabric of matter and energy, the past still exists. Let me give you an example. Imagine you're walking on a beach. The sand is smooth and untouched. You take a step, your foot presses down, and the sand shifts. Grains are displaced. Some are pushed to the side. Others are compacted beneath your weight. And when you lift your foot, there it is. A footprint. That footprint is a record, a trace, a physical memory of something that happened. The event, your step, is over. You're already walking away, but the information about that event is still there, frozen in the arrangement of the sand. At every step, the information becomes more diffuse, more scattered, harder to read. But it's never erased. It's just transformed into a form so complex, so tangled, that reconstructing it becomes impossible in practice. But in principle, the universe still remembers. Feynman had a deep appreciation for this idea. He understood that the laws of physics are, in a sense, reversible. If you could know the exact position and velocity of every particle in the universe, and if you could run the equations backward, you could, in theory, reconstruct everything that ever happened. You could rewind the universe like a film and watch the past unfold in perfect detail. Of course, you can't actually do this. The universe is far too complex. There are too many particles, too many interactions, too much chaos. But the point is, the information is still there. The past hasn't been deleted. It's just been scrambled into the present. Think about it. Every atom in your body has a history. It was once part of a star, then part of a cloud of gas, then part of the earth, then part of a plant, or an animal, or the air. And now it's part of you. That atom has been through countless events, countless transformations, and in some faint, untraceable way, it still carries the echo of everything it's ever been. This is what Feynman meant when he talked about the universe as a continuous, unbroken process. There are no hard cuts, no moments where the universe stops, erases the board and starts fresh. Everything flows into everything else. The past doesn't vanish, it becomes the present, and the present will become the future. It's all one long, interconnected story. So when you say the past is lost, what you really mean is, I can no longer read the story clearly, but the story itself, it's still being told. In the motion of atoms, in the spreading of heat, in the faint hum of radiation left over from the Big Bang. The universe never forgets. It only transforms. But if the universe remembers everything, why does it feel like the past is gone? Excipic, Chapter 4. Memory isn't stored. It's embedded. Let's talk about memory for a moment. Not the poetic kind. Not the bittersweet feeling of remembering a summer afternoon or a friend's laugh. Let's talk about memory as a physical thing, because that's what it is. When you remember something, you're not pulling a file out of a drawer in your brain. You're not accessing a recording that was saved somewhere, perfectly preserved. That's not how memory works. Memory is a pattern of connections between neurons, a pattern that was shaped gradually by experience. When something happens to you, when you see a face, hear a song, feel a touch, your brain changes. Neurons fire, synapses strengthen, chemicals flow, and the structure of your brain shifts, ever so slightly, to reflect that experience. That shift is the memory. The memory isn't stored in one place. It's distributed across thousands, maybe millions of neurons. It's embedded in the way they connect to each other, in the strengths of those connections, in the likelihood that one neuron will trigger another. And here's the key. That structure is made of matter, atoms, molecules, physical stuff. Which means the memory isn't just a mental event. It's a physical change in the universe. An event in the past has literally rearranged the matter in your brain. So when you say, I remember yesterday, what you're really saying is, yesterday changed me, and I am the evidence that it happened. You are the footprint. But this doesn't just apply to brains, it applies to everything. A tree grows in the shape it does because of the sunlight it received, the wind that bent it, the soil that nourished it. Its form is a memory of all those influences. A rock is smooth because water flowed over it for centuries. Its surface is a memory of that motion. The air in a room carries faint traces of sound waves that passed through it moments ago. Those waves are gone, but their effects, tiny changes in pressure, temperature, density, linger for a fraction of a second longer. Feynman loved this perspective. He had a way of seeing the world not as a collection of separate objects, but as a web of relationships. Every particle affects every other particle. Every event leaves a mark, and those marks accumulate, layer upon layer, into the present. Now, it's true that memories fade, neurons die, synapses weaken, the details blur, and eventually some memories become completely inaccessible. You forget. But forgetting doesn't mean the information was destroyed. It's like writing in sand again. The message is clear at first, but as more feet walk over it, as more wind blows, the letters smudge. Eventually you can't read the message anymore. But the sand itself, still there, still shaped faintly by everything that happened to it. This is why memory feels so strange, so unreliable, so tied to emotion and context. Because it's not a recording. It's a living, changing structure. It's the present wearing the past like a layer of old paint. And memory doesn't live only inside us, it spills quietly into the world. Hafter. Chapter 5. How every moment leaves a physical trace. Let's go deeper, because it's not just memories in brains or footprints in sand. Every moment, every single event, no matter how small, leaves a trace in the physical world. Think about sound. You speak. Your vocal cords vibrate. Those vibrations push air molecules. The air molecules push other air molecules. A wave of pressure moves outward, traveling through the room at the speed of sound. That wave hits your ear. It vibrates your eardrum. Your brain interprets it. You hear the words, and then the sound is gone, right? Not quite. The wave continues. It spreads beyond your ear. It bounces off walls. It travels down hallways. Some of it escapes through windows. Some of it is absorbed by curtains, furniture, your clothes. But even when it's absorbed, the energy doesn't disappear. It turns into heat, microscopic vibrations of molecules. A tiny, immeasurable increase in temperature. That heat spreads. It radiates. It mixes with the surrounding air. Eventually, it becomes indistinguishable from the background thermal noise of the environment. But it's still there. The energy you put into the air when you spoke, that energy still exists. It's just been transformed, diluted, scattered across billions of molecules. In principle, if you knew the exact state of every molecule in the room, their positions, velocities, temperatures, you could, in theory, trace the energy backward. You could reconstruct the sound wave. You could hear mathematically what was said. Of course, in practice, this is impossible. The information has spread too far. It's mixed with too many other signals. The universe is too noisy, too chaotic, too interconnected. But the point stands. Nothing simply disappears. The same is true for light. When you turn on a lamp, photons stream outward. They bounce off objects. Some are absorbed, some are reflected, and some escape, out the window, into the night sky, traveling at the speed of light. Those photons carry information. They carry an image of the room, frozen in light. And they keep going. They travel across the street, across the city, across the planet. Some of them even escape into space, racing outward toward distant stars. Feynman loved to point this out. Every event that involves light, every glance, every sunrise, every flickering candle, sends information outward at the speed of light. That information is still traveling. Right now, photons that bounced off your face yesterday are billions of miles away. In principle, if an alien civilization had a powerful enough telescope pointed in exactly the right direction, they could see you as you were yesterday. The past isn't behind you. It's ahead of you, traveling at light speed. And it's not just light and sound, it's everything. This is what physicists mean when they say information is conserved. Not that it stays in one place, not that it remains readable, but that it never truly vanishes. It just spreads out, blending into the infinite complexity of the universe. So when you ask, where did the past go? The answer is, everywhere. It's in the air you're breathing, in the light around you, in the atoms of your body, in the faint hum of thermal radiation filling the cosmos. The past is not a place you left behind. It's a wave still spreading, a trace still fading, a story still being written in every particle, every field, every flicker of energy. If traces of the past are everywhere, could they in principle be followed back? So, Chapter 6. Why we can't rewind time, even if the past still exists. So here's where things get interesting. If the past is still embedded in the present, if every event leaves a trace and information is never truly destroyed, then why can't we just reverse it? Why can't we take all those scattered traces, all that diffused energy, and run the process backward? Why can't we unbreak the glass, unspeak the words, unlive the moment? The answer, Feynman would tell you, comes down to a single concept: entropy. Now don't worry, this isn't going to be a math lecture. Feynman hated unnecessary abstraction. He believed that if you really understood something, you could explain it without jargon. So let's talk about entropy the way he would. Imagine a glass of water sitting on a table. You knock it over. The glass falls. It hits the floor. It shatters. Water spreads across the tile. Shards of glass scatter in every direction. Now, here's the question. Could this process happen in reverse? Could the water by pure chance flow back together? Could the shards slide across the floor, leap into the air, and reassemble into a perfect glass? Could the glass then jump back onto the table, full and unbroken? Technically, yes. The laws of physics don't forbid it. If every molecule of water and every atom in the glass happened to move in exactly the right way, at exactly the right moment, the process could reverse. The equations allow it, but it's so staggeringly unlikely that it might as well be impossible. Why? Because there are countless ways for the glass to be broken, and only one way for it to be whole. There are trillions of configurations where the water is spread out, and only a tiny handful where it's neatly contained. The universe, left to itself, always moves toward the configurations that are more probable, and those configurations are the messy ones, the scattered ones, the disordered ones. This is entropy, not chaos exactly, but a measure of how spread out, how mixed, how disordered a system is. And the universe as a whole is always moving toward higher entropy, toward more disorder, toward more ways things can be arranged. This is why you can't unscramble an egg, why you can't unburn a piece of paper, why you can't gather all the sound waves you've ever spoken and replay them backward. Not because the information is gone, but because it's been scattered into so many places, mixed with so many other signals, that untangling it would require you to know and control every single particle involved, and that's just not possible. This is why time feels irreversible. This is why the past feels gone. Not because it was erased, but because the universe is too complicated to read backward, so the past isn't lost, it's just scrambled beyond recognition. Hecht! Chapter 7. The Arrow of Time and the Illusion of Forward Motion. There's something strange about time, the laws of physics. The equations that describe how particles move, how energy flows, how forces act, don't care which direction time goes. If you filmed a single electron moving through space and played the video backward, the motion would still obey the laws of physics. It would look just as valid, just as real. And yet, in the world we experience, time only goes one way. We remember the past. We don't remember the future. We see causes before effects. We watch things break, not repair themselves. We grow older, not younger. This one-way flow, this sense that time has a direction, is what physicists call the arrow of time. And here's the strange part. The arrow of time isn't written into the fundamental laws of the universe. It's not a rule that says time must flow forward. It's a consequence of entropy, of the fact that the universe started in a low entropy state and has been moving toward higher entropy ever since. Think back to that broken glass. The reason you see it shatter and never see it unshatter is because the shattering increases entropy. The reverse process would decrease entropy, which is technically possible but overwhelmingly unlikely. So the arrow of time, the feeling that time moves forward, is really just a statistical fact. It's the universe exploring more and more probable configurations. And because we are part of that process, because our brains operate by increasing entropy, we experience time as flowing in one direction. But from the universe's perspective, there's no real past or future. There's just a series of configurations, each flowing into the next, governed by the same timeless laws. So why does it feel like time is moving? Because you're a process, a pattern of matter and energy, constantly changing, constantly flowing toward higher entropy. You can't step outside of time and watch it from a distance. You're inside it. You are it. And because of that, you experience causation. You experience memory. You experience the forward flow. But here's the beautiful part. Even though time flows forward, even though entropy increases, even though the past becomes harder and harder to read, it's never truly gone. Every moment you've ever lived is still woven into the present. Every choice, every word, every breath, it's all still here, embedded in the structure of the universe. You just can't rewind the tape. And yet, despite this forward arrow, the past still quietly shakes every now. Ugh. Chapter 8. You are made of the past. Let's bring this home, because there's one more piece to this story. One more way the past is still present, and it's closer than you think. It's you. Right now, as you sit here, your body is made of atoms, roughly 7 octillion of them. That's a 7 followed by 27 zeros. And every single one of those atoms has a history. The hydrogen in your body, the simplest, lightest element, was forged in the first few minutes after the Big Bang, nearly 14 billion years ago. The carbon, the oxygen, the nitrogen, the elements that make up most of your cells were created inside stars, ancient stars that burned for millions of years, fusing lighter elements into heavier ones until they finally exploded in supernovae, scattering those elements across the galaxy. The iron in your blood was made in the violent core of a dying star in the last seconds before it collapsed. All of this matter, the matter that makes up your bones, your skin, your brain, drifted through space for eons. It was part of gas clouds, part of asteroids, part of the early Earth. It cycled through oceans, rocks, plants, animals, and now it's part of you. You are not separate from the past. You are made of it. Every atom in your body carries the story of the universe. Every cell is a chapter in a book that's been writing itself for billions of years. And it's not just the atoms, it's the patterns, the information, the structure. Your DNA is a record, a long twisted strand of instructions that have been passed down, generation after generation, for hundreds of millions of years. Every mutation, every adaptation, every survival. It's all encoded in your genes. Your thoughts, your memories, your sense of self. All of it is built on the foundation of everything that came before. Your parents shaped you. Your environment shaped you. Your experiences shaped you. You are the living accumulation of countless moments, countless influences, countless causes. H.E. Pro. Chapter 9. What Feynman might say about letting go now. You might be thinking, okay, so the past isn't really gone. It's embedded in the universe. It's inside me. It's scattered across space and time. But, so what? I still can't go back. I still can't change it. I still can't hold on to the moments that mattered. And you're right, you can't. But Feynman would probably tell you that that's okay, because the point isn't to hold on. The point is to understand. Feynman had a kind of philosophical calm about him. He wasn't interested in comforting illusions or easy answers. He wanted to see the universe as it really was, and he believed that once you understood how things actually worked, you could find a kind of peace in that understanding. Yes, the past is gone in the sense that you can't return to it, you can't rewind, you can't undo. The universe only moves forward, and you move with it. But that doesn't mean the past is meaningless. It doesn't mean it was wasted, or lost, or erased. It means it became something else. It became the present, it became you, and there's something beautiful in that. Because if you can let go of the need to hold on, if you can accept that moments pass, that things change, that the universe flows forward, then you can stop fighting against time. You can stop grieving every second that slips away. You can just be here, in this moment, knowing that this moment too will become part of the pattern, part of the story, part of the endless transformation that is the universe. Feynman wasn't sentimental, but he was deeply curious, and he believed that curiosity, the desire to understand, to explore, to see more clearly, was one of the most meaningful things a person could have. So maybe the lesson here isn't about holding on to the past. Maybe it's about understanding it well enough to let it go. Not because it's gone, but because it's already part of everything. And with that understanding, we arrive at a quieter, more peaceful conclusion, as to H. Sharp. Chapter 10. The past was never lost. Only quiet, so here we are, at the end of this quiet journey. And maybe now the original question feels different. Is the past really lost? Not in the way we thought. Not erased. Not vanished. Not gone. Just transformed. Scattered. Woven into the fabric of everything. The past is in the light that left your window yesterday, and is now halfway to the moon. It's in the heat still radiating from a cup of coffee you drank this morning. It's in the air you breathed a moment ago, now mixed with the breeze outside. It's in your cells, in your memories, in the shape of your thoughts. The past isn't loud. It doesn't announce itself. But it's everywhere, and the universe, this vast, ancient, endlessly transforming universe, carries it forward. Always. Richard Feynman spent his life trying to understand how the universe works. Not to control it, not to fix it, just to see it more clearly. And one of the things he saw was this. Nothing is ever truly lost. Energy is conserved. Information is preserved. The story continues. So maybe the past isn't something to mourn. Maybe it's something to appreciate, to recognize, to carry with you quietly as you move forward. Because the past isn't behind you. It's beneath you, around you, inside you. It's the foundation you're standing on, the thread you're woven from, the echo that shapes every sound you make. The past was never lost. It was only quiet. And if you listen closely, if you pay attention to the atoms and the light and the slow unfolding of time, you can still hear it, faintly, gently, like a song that never really ended. It just changed key.